Hello, my name's Chris Mack, and I'm the professor for a course entitled From Data to Decisions, Measurement, Uncertainty, Analysis, and Modeling. This is a course I've taught for the last few years at the University of Texas at Austin, and I'm now in the process of recording those lectures and putting them online. This lecture, maybe we'll call it Lecture 0, is an introduction. It will help you understand what this course is about and whether you think these lectures are right for you. Let's begin by talking about the course website. As listed here on my personal web page, we have the website for the class. And on this website, you'll see the links to the video lectures. All the video lectures will be on YouTube, but we'll have links to each of them in the proper order, links to reading materials to supplement and support those video lectures, homework problems, and maybe what's most important, a set of Excel spreadsheets with data sets and example problems. After all, this is a data analysis kind of a class. The way you really learn is not just listening to these lectures, but actually practicing the concepts on real data sets. And that's what we'll be doing a lot of in this course. So let's talk about what this course is about. First of all, this is not an introductory course on probability and statistics. Almost every engineer or scientist as an undergraduate will take a 1 semester, 3 credit hour, or something like that, course on probability and statistics. Everybody needs that. That's kind of a basic to even understand what science and engineering is all about. But in my opinion, that is not enough to actually work with data in the real world. Instead, we need more than just the basics. And this course is going to provide something that goes beyond the lessons that you've learned in an introductory course. We're going to talk about the problems, the kind of real-world problems that people deal with when they encounter data. They have to do analysis of that data and then make decisions based on that analysis. I'm not going to read all of these items. You can read them for yourself. In the end, though, my goal is for the student to have the tools that they need when they encounter real problems that involve data and data analysis. And ultimately, what I would hope, and this is maybe just slightly beyond the scope of this class, maybe just a little bit more than we'll actually be able to get to, but I hope to move you towards the following scenario. I've got a set of data. I've got two competing models, two competing theories, two competing ways of analyzing that data and saying, and here's one explanation versus a different explanation that describes the data and allows you to make predictions about future experiments. And I want to know, does the data set give me enough information to choose one theory over another, to say this theory better describes what's happening in the world compared to that one? That's a really hard thing to do in many, many circumstances, and it takes very careful examination of what the data is telling you. So that's another way of thinking about this course, is given a set of data, and data can be really expensive and hard to collect. Given a set of data, how can you maximize the information, the knowledge that you extract from that data? The topics covered. First, I'm going to assume that you already know the basics of statistics. So if you don't, or if it's been a while since you've looked at your introductory statistics coursework, the pre-work for this class, what you should do before you get to Lecture 1 is to review statistics, review regression, review the ideas of goodness of fit. And I'll give you some resources to help you do that. Of course, if you just finished a statistics class or you feel very comfortable with that introductory material, you may not need to do that pre-work. We'll begin with an introduction to show you some motivation of why you need to go beyond that introductory material. We will do a little review of regression, but I'll assume that you're already familiar with it. Then we're going to look at diagnostics of that regression. We're going to test for normality, outliers. We'll talk about concepts of leverage and influence, which maybe you haven't heard of before, but very important to good regression, and heteroscedasticity, one of the fanciest words we're going to use in this class. We'll talk about some more sophisticated types of regression analysis, weighted linear regression, total regression, and how those things relate to model error. We'll talk about multiple regression, in one sense a fairly simple extension of our normal regression analysis, model fitting. We'll talk about analysis of the residuals and two very, very difficult problems that can exist, or one related problem, depending on how you look at it, that can exist in our models if residuals are not independent of each other. And in the world of time series, we deal with something called the autocorrelation of the data. And probably the most difficult problem to deal with in terms of multiple regression is multi-collinearity. Now, if you're at this point in reading over these topics and you're hearing a bunch of words you've never heard of before, this goes to show you that introductory statistics doesn't cover topics like these that are extremely important when doing real-world sophisticated analysis, the kind of analysis that you want to do before you, say, publish a paper using regression analysis of data. We'll talk about building models. The ultimate goal of all of this work is to create some kind of a model that we can use to make predictions. And some of the more sophisticated or advanced types of regression that go beyond the introductory level are topics like robust regression and Bayesian regression. Now, I have to admit, we're only going to touch on these very briefly. We're not going to go into details. You can have an entire course on robust regression, an entire course on Bayesian regression. We're going to talk about design of experiments, on response surface modeling, and then we'll sum up by going back to the beginning and talking about measurement uncertainty, and how that uncertainty propagates throughout our models. And we'll kind of loop around to how that feeds into regression. So quickly, some prerequisites. I expect everyone to be very good at calculus. All right? I don't know if you're an engineer, scientist in your junior or senior years, or a graduate student, then you should remember differential and integral calculus, using that, of course. But I also expect you to already know introductory probability and statistics. And I have created a review course, an online review course if it's been some years since you've taken a probability and statistics class, go through this review course and make sure you're up to speed on the basics. This review is the equivalent of about 3 weeks of a typical course, lectures a week. So you should be able to get through it in just a few days if you concentrate it. And I also expect you to have a working knowledge of Excel. We'll be using Excel spreadsheets and much of our data analysis. It's not the only software we'll use, but it's kind of the standard one because every working scientist and engineer usually spends a lot of time in Excel. With that in mind, I think this class is suitable for junior and senior science and engineering majors. But its real motivation is graduate students, because I've seen a lot of graduate students at the University of Texas who have come across their real-world introduction to using data. They collect some data. Maybe they design the experiments or build the equipment that's used to collect that data. Now they have to do analysis and maybe present that data for the first time paper. And they find that their data analysis skills are just really not up to speed. So one of my goals is if you're, say, a first-year graduate student or just beginning to collect data as a graduate student, to give you the skills that you need so you can be confident when you present this analysis in a paper that you're doing the best work that you can do. You're doing the kind of work that people expect in a peer-reviewed publication. So that's my introduction. Thank you for listening. Good luck, and visit the website for lecture number 1. Thank you.